Hi guys, welcome back. Today I just wanted to look at a question for rates of reactions. So how do we approach analyzing the question and all of that, right? So there's a question given to us here where it's a reaction between excess dilute HCl, which means zinc is the limiting reagent, and then they say they conduct two experiments and they give a summary of the reaction conditions, right? So what is the same when we are looking at an investigation, an experiment? Then we have to figure out our variables, right? So what is the same in all of these? One, the temperature is kept constant, and the volume of the HCl is also the same, right? It does not change. But what changes is the concentration in reaction 1 is lower than the concentration in reaction 2. So obviously that is going to affect the rate of the reaction because of the factors that affect the rate of the reaction. Concentration is one of them. So already you should be thinking that the one with the concentration of 0.4 moles per cubic decimeter should be a faster reaction rate, higher reaction rate than the one of 0.25, right? That's the first thing. So always analyze before moving on. Then they say the graph is of H2, and H2 is the product. That is the graph that they are showing there. And then in that graph, there is P and Q obtained. The results are obtained and shown in the graph. So it means what's shown here in the graph is for experiment 1 and experiment 2. So something you should be able to figure out now that we've said the reaction for number 2, the experiment for number 2 is going to be a faster reaction rate than the experiment for number 1. You should already see that. Remember we said the steepness, it correlates to the rate of the reaction. So this one is steeper than this one, right? Which means the P should be the graph that represents the experiment with a higher reaction rate, which is the one that has a higher concentration. So this one would be for number 2. So P should be the graph for number 2, and Q should be the graph for number 1. So always analyze before going into questions, right? Now we can go to the questions. The first question says that define rate of reaction, which is the change in the concentration of the product or the reactants per unit time, right? Write down an investigative question. So investigative question, the key things that must be there is that there must be an independent variable. There must be an independent variable, and your dependent variable must also be identified before you can write an investigative question, right? So what is changing is your independent variable. What changes between the conditions they have in reaction 1 and the conditions they have in reaction 2? We already spoke about it. We said the concentration is not the same, which means the independent variable is what? It's the concentration. So what changes? What changes? Right? So that is the concentration. And then what is being measured? They're measuring the amount of H2 produced over a period of time, which relates to the rate of the reaction, right? Because they say they are investigating the factors that affect the rate of the reaction. So what is being measured is what is measured or tracked after the change is made is the rate of the reaction, right? Rate of reaction. Then when you write an independent variable, don't mix up the cause and effect. So the change made to the independent variable results in whatever being measured, being affected. So what I mean by that is I can say, how does the rate of the reaction affect the concentration? it's not, the change is not being made on the rate of the reaction, but it's being made on the concentration, and then the rate of the reaction is measured, right? So how I write it, it should not be the wrong way around. And also always remember that the investigative question, the answer to an investigative question should not be a yes or no, right? The answer should not be yes or no. So what does that mean? Yes or no, right? So if I ask you, does the concentration change the rate of the reaction? How are you going to answer me? You can either say yes or no. Then that means what I just said doesn't qualify as an investigative question, right? So correct investigative question would be something like, how does the change in concentration affect the rate of the reaction, right? How does the change in concentration affect the rate of the reaction? That's an example of an investigative question. So let's write that then. That would be our number 8.2, right? And then moving on to number 8.3, which we've already answered because we analyzed our information, always analyze before. We've already answered that. So let me write this down. How does a change in concentration affect the rate of the reaction? Right? Moving on to number 8.3. Number 8.3 we've already answered. Why? Because when we're analyzing, we checked which graph belongs to which experiment. So we've already answered that. 8.3, it says, which curve, P or Q, represents the results of experiment number 1? And that would be curve Q. I've already explained that one. And then 8.4 says, the average rate of of production of hydrogen gas as represented by the graph was 15 cubic centimeters per second. Calculate the mass of zinc used, right? It's very important when you're reading to highlight some key things. So one of the key things is that the rate of the reaction is given in cubic centimeters per second, right? And it's the volume of the H2. So when I calculate using this rate, I can easily work out the volume I have of the H2. And then remember that the mass of zinc used determines the amount of product that was formed. So if I have the amount of hydrogen gas formed, I can then use the mole ratio and work back to get the mass of the zinc that was used by first getting the number of moles of zinc that was used, right? So let's work on that. And then they give us the molar gas volume 25 degrees as 24,000. So I have the option of either using it as 24,000 cubic centimeters, or I can convert it to cubic decimeters. It will all reach the same answer. It really doesn't matter, right? So let's look at that. 8.4, I said where are we starting? So you always begin with the end in mind. I've already figured out where I'm going. Now I can start. I can start by first saying the rate is equal to change in V over change in T, right? And then the rate, which is given as 15, is going to give me, it can be able to get me the volume, which is in cubic centimeters. So average rate for the first 30 minutes, right? Average rate for the first 30 minutes, you'll see that reaction P would have already reached completion. So everything would have been used up. That's why we are able to get how much of the reactant, the limiting reactant rather, would have been used up. So I can substitute here. I've got change in V, which is going to be the volume of hydrogen, The time, it's 30 minus 0, and the rate is 15, right? You can quickly calculate that, and you should get 450 cubic centimeters, right? That is the volume of H2 produced. And they said at this specific temperature, this is the molar gas volume, so 1 mole occupies this much, right? So I can use the Avogadro's law, which is I can use the volume of 450 and the molar volume of 24,000. Remember, I can be able to use cubic centimeters and cubic centimeters. So you must always check your units, right? Then I can work on those units as they are. Otherwise, if I change one of them, then I must change the other as well, right? So I can calculate that, and let's quickly calculate that. I get 0.0188 mole, right? That's the number of moles of the H2 that was formed. The number of moles of the H2 that was formed, right? And then from there on, I can use that to calculate or to get the number of moles of the zinc, because that's where I'm going, right? So a number of moles of zinc I can find first using the mole ratio of zinc is to H2. The ratio, if you check the reaction, is 1:1, right? So the ratio is 1:1. Here I've got 0.0188, and here I've got the number of mole of zinc used. That's what I'm looking for, right? So obviously the number of moles of zinc used is going to be equal to 0.0188. I'm writing 0.0188, but I got 0.01875. So remember, you only round off your final answer. So along the way, use your full answer as you got it from in your sub steps, right? Then from there on, I can be able to now get the mass using N is equal to M over M. I have the number of moles, 0.0188, and the molar mass of zinc is 65, right? And I can get the mass. I can get the mass there. Let's quickly get that. And that's how we should get a mass of 1.22 grams, right? I hope this has helped you. Please subscribe and refer your friends as well that may find this helpful. How to analyze questions, how to answer and approach questions. Make sure that you always analyze before rushing to go to the questions. See you on the next video.